Hello students, and today once again we are going to discuss few questions from continuity chapter. The first question, f of x equal to root 3 sin x plus cos x divided by x plus pi by 6, where x not equal to minus pi by 6. When x equal to minus pi by 6k, the function is continuous at x equal to minus pi by 6, then we would find the value of k. So for left limit as well as right limit, same function mean we can take right hand limit. Limit x approaches minus pi by 6 on the right side. F of x will be equal to f of minus pi by 6. So f of minus pi by 6 from the question k. Then this implies limit x approaches minus pi by 6 from right side. Root of 3 sin x plus cos x by x plus pi by 6 is equal to k. Then limit x approaches minus pi by 6 from right side. A small adjustment required. Just multiply divided by 2. 2 times root 3 by 2 sin x plus 1 by 2 cos x. So divided by pi plus pi by 6 is equal to k, and this implies limit x approaches minus pi by 6 from right hand side, then 2 times this can be written as 1 by 2 sin pi by 6, sin 30 equal to 1 by 2, root 3 by 2 cos pi by 6. So cos pi by 6 sin x plus sin pi by 6 cos x. So sin of x plus pi by 6. So this also x. So divided by x plus pi by 6 is equal to k. Okay. So we have reduced root of 3 sin x plus cos x as 2 times sin of x plus pi by 6 following trigonometric identities as you learned from your 11th standard. Now in order to eliminate the superscript, let us introduce the smallest positive number which approaches 0, then 2 sin of what is x value minus pi by 6 plus h. Minus pi by 6 plus h, already pi by 6. So divided by x equal to minus pi by 6 plus h plus pi by 6 is equal to k. If we simplify a limit h approaches 0, minus pi by 6 and plus pi by 6 cancel. 2 sin h by h alone. These two also cancel. 2 times sin h by h is equal to k. Applying sandwich theorem, the limit of sin h by x equal to 1. So 2 times 1 equal to k, and therefore k equal to 2. So when k equal to 2, the given function is continuous at x equal to minus pi by 6. So dear student, we will discuss one more similar question. The next question, f of x has 2 branches including these 3 branches. For x less than 0 is a combination of 2 sine function, x greater than 0, this is one rational expression, okay, involving square root function and x. So what is given? The function is continuous at x equal to 0. Now the left limit or right limit of this function should be equal to f of 0 equal to 2. So limit x approaches 0 from left side, or limit x approaches 0 from right side must be equal to f of 0, that is 2. We can discuss one by one. So limit x approaches 0 minus f of x is equal to and 2. So this implies limit x approaches 0 from left side and sine of a minus 1 into x plus 4 sine x upon x equal to 2. Then this implies limit h approaches 0, then sine of a minus 1 into minus h plus 4 sine of minus h divided by minus is equal to 0. Don't cancel between these two, this is not a factor. Including a minus 1 into minus h is the angle of the sine function. Then this implies limit h approaches 0 and sine of a minus 1 h by h plus 4 sine of h by h is equal to 2. Okay. Applying sandwich theorem on these two terms, according to sandwich theorem, and sin theta by theta equal to 1 whenever theta approaches 0. So this limit of first term is going to be a minus 1, the second term 4, a minus 1 plus 4 equal to 2, and this implies a equal to minus 1 plus 4 equal to plus 3 on the other side minus 3, 2 minus 3 is minus 1. So a equal to minus 1. Okay, a equal to minus 1. Now the right hand limit x approaches 0 plus and f of x must be equal to f of 2. It is not f of 2, f of 0, that is f of 0 is 2. Now we can take the values of f of x in the particular branch. X approaches 0 plus means x greater than 0. What is f of x? Root of 1 minus bx minus 1 by x is equal to 2. If you apply the limit 0 by 0, indeterminate form will come. To avoid indeterminate form, we have to rationalize limit x approaches 0 plus 1 minus bx minus 1 and divided by x in the root of 1 minus bx plus 1 is equal to 2. Then plus 1 minus 1 cancel, x and x cancel. Now limit x approaches 0 plus minus b divided by root of 1 minus bx and plus 1 is equal to 2. To eliminate the superscript h, let us introduce the smallest integer h approaches 0 minus b by 1 minus bh under root plus 1 equal to 2. Applying limit, the limit on the left side, bh term is going to be 0, root of 1 is 1, this is root of 1, root of 1 plus 1 2 minus b by 2 minus b by 2 is equal to 2, then this implies b equal to minus 4, therefore a equal to minus 1 and b equal to minus 4. So this is the final answer. So dear student, we will discuss one more question. The next question, a little big problem. The first branch x plus sin x divided by sin of a plus 1 into x in the interval minus pi to 0 when x equal to 0 to x greater than 0 some other function given. It is given the function is continuous at x equal to 0, then we should find the values of a and b. So the left limit and right limit should be equal to f of 0. Actually, what is the point? Limit x approaches 0 minus f of x and limit x approaches 0 plus f of x must be equal to f of 0. F of 0 from the question, f of 0 equal to 2. So left limit must be 2 and right limit also 2. Okay, so we can start from left hand limit. Limit x approaches 0 from left side f of x, the value must be 2 because the function is continuous at x equal to 0. The limit x approaches 0 minus, what is f of x? X plus sin x by sin of a plus 1 into x is equal to 2. To get the limit, better we can do all the three terms can be divided by x. So limit x approaches 0 minus 1 plus sin x by x, then sin of a plus 1 into x by x, okay, is equal to 2. We can introduce the smallest positive number h approaches 0, then 1 plus sin of minus h by minus h divided by sin of a plus 1 into minus h by minus h equal to 2. If we continue with the simplified part of the previous term and sin of minus theta minus sin theta, so limit h approaches 0, 1 plus sin h by h divided by sin of a plus 1 h by h equal to 2. Applying sandwich theorem on these two terms, the limit of 1, the limit of sin h by h 1, the limit of sin of a plus 1 h by h a plus 1 is equal to 2. Then 2 and 2 cancel, then this implies a plus 1 is equal to 1. 2 cancel, here 1 by a plus 1 equal to 1, then a plus 1 equal to 1, this implies a equal to 0. Now, limit x approaches 0 minus f of x must be equal to f of 0, that is 2. Then limit x approaches 0 minus 2 times e power sin bx minus 1 by bx is equal to 2. The limit x approaches 0 minus 2 times e power sin bx minus 1 by, here we can do the small adjustment, and sin bx into bx by sin bx is equal to 2. In order to apply the standard result, e power 5 minus 1 by 5 is equal to 1 whenever limit 5 approaches 0. Remember the result. In order to apply this result, we need this kind of adjustment required. It's very important adjustment. Now we can separate this one part, this another part. So applying standard theorem, and 2 into the limit of e power sin bx minus 1 by sin bx 1 by the limit of bx by sin bx also 1 is equal to 2. Okay, so 2 equal to 2 mean then the left hand limit, the right hand limit also, this is 0 minus, this is 0 plus, 0 plus right side, this is right side. So this shows that the left limit and right limit both equal to 2. So b can be any real number. B can be any real number, and a should be 0. So when a equal to 0 and b is any real number, the function is continuous at x equal to 0. Then we will discuss one more question. The next question, f of x equal to sin x minus cos x by by 4x minus pi whenever x is not equal to pi by 4. When x equal to pi by 4, f of x equal to k is continuous at x equal to pi by 4, then find the value of k. This is also one of the routine question. Then here left limit, right limit, same function. So limit x approaches pi by 4 from left side, or limit x approaches pi by 4 from right side should be equal to f of pi by 4 is nothing but k. Now we can take no right hand limit. Limit x approaches pi by 4 plus f of x is equal to k, and this implies limit x approaches pi by 4 plus and sin x minus cos x by 4x minus pi is equal to k. Here we can do a small adjustment. The limit x approaches pi by 4 plus root of 2 times 1 by root of 2 sin x minus 1 by root of 2 and cos x is divided by 4x minus pi equal to k. Then this implies limit x approaches pi by 4 plus, so this can be written cos pi by 4 and sin pi by 4, sin x cos pi by 4 minus cos x sin pi by 4 and root of 2 times and sin of x minus pi by 4. We take 4 common, 4 into x minus pi by 4 is equal to k. We can take a root of 2 by 4, that is 1 by 2 root of 2 outside the limiting part. So this implies 1 by 2 root of 2 limit x approaches pi by 4 plus and sin of x minus pi by 4 divided by x minus pi by 4 is equal to k. So to eliminate the superscript plus usual things, we can introduce a smallest positive number, h approaches 0, then x equal to pi by 4 plus h because of right hand limit minus pi by 4 divided by, for x equal to pi by 4 plus h minus pi by 4 is equal to k. This and this cancel. Then this implies 1 by 2 root of 2 limit h approaches 0 sin h by h by Sandwich theorem, the limit equal to 1, then this implies k equal to 1 by 2 root of 2. Okay, so dear student, to support me and my effort, please convey about my channel name Murugaiyyan Subramanian to your friends of your school and other school student. Thank you.